1. Let's solve the problems based on the concept of solid state. The first question goes in this way. A cubic unit cell is made up of three elements X, Y and Z. Atoms of X are present at the corners, atoms of Y at the cube center and atoms of Z at the center of each face. What is the formula of the compound? Let's solve this problem. There are 8 corners in a unit cell. 8 atoms of X occupies them. Therefore, the contribution of X atoms per unit cell is given as 8 into 1 by 8. Addition to that, we also have cube center which is occupied by only one atom in a unit cell. Therefore, the contribution of Y atom per unit cell is given as 1 into 1. Along with this, we also have 6 faces of unit cell and the center of each face is occupied by Z atoms. Therefore, the contribution of Z atoms per unit cell is given as 6 into half. By solving the above, we get 1 plus 1 plus 3. Therefore, the ratio of atoms in a unit cell X is to Y is to Z can be given as 1 is to 1 is to 3. Hence, the formula of the compound is X, Y, Z 3. Moving on to the next question. Two elements A and B crystallizes in a cubic unit cell with atoms of A at the corners and atoms of B at the face centers. If 2 atoms of A are missing from the corners and 2 atoms of B from the face centers, what is the formula of the compound? There are 8 corners in a unit cell. Each corner consists of the atoms of A and 2 atoms are missing. Hence, only 6 corners are filled. Therefore, the contribution of A in this unit cell is 6 into 1 by 8 which is equal to 3 by 4. Similarly, there are 6 faces in the unit cell. Each face consists of the atoms of B and 2 atoms are missing. Hence, only 4 faces are filled. Therefore, the contribution of B atoms in the unit cell is 4 into half which is equal to 2. The ratio of atoms in this unit cell is A is to B which is equal to 3 by 4 is to 2. On multiplying with the common factor of 4, the above ratio of atoms becomes A is to B which is equal to 3 is to 8. Therefore, the formula of the compound is A3B8. The next question is, sodium crystallizes in a body-centered cubic unit cell. Calculate the approximate number of unit cells present in 9.2 gram of sodium. Given atomic mass of sodium as 23 gram per mole. Let's move on to the solution. A body-centered cubic unit cell consists of 8 atoms in its corner and 1 atom within its body. Therefore, the contribution of the sodium atoms present in the corner of the unit cell is 8 into 1 by 8 which is equal to 1. Secondly, the contribution of the other atom present within the body of the unit cell is 1 into 1 which is equal to 1. Hence, the number of atoms present in BCC, that is body-centered cubic cell, is 1 plus 1 which is equal to 2. And the number of atoms present in 1 mole of sodium is the Avogadro number of atoms, and we know the value of Avogadro number as 6.023 into 10 to the power 23. And the atomic mass of sodium is 23. Therefore, the approximate number of unit cells present in 9.2 gram of sodium is 6.023 into 10 to the power 23 multiplied by 9.2 gram of sodium divided by its atomic mass, and the number of atoms per BCC is 2. By solving this, we get 1.204 into 10 to the power 23. Moving on to the next question, the question states in this way. In calcium fluoride crystal, Ca2 plus ions are present in face-centered cubic arrangement. Calculate the number of F minus ions in the unit cell. Let's find the solution for this question. Ca2 plus ions of calcium fluoride occupy 8 corners and 6 faces of the face-centered cubic unit cell. F minus ion occupy all the tetrahedral voids created due to the arrangement. Each Ca2 plus ion is surrounded by 8 F minus ions. Each F minus ion is surrounded by 4 Ca2 plus ions. Therefore, the contribution of Ca2 plus ion in this unit cell is 8 into 1 by 8 plus 6 into half, which is equal to 4. And we know that the number of tetrahedral voids is equal to 2 into number of particles present in FCC. Therefore, the number of tetrahedral voids are 2 into 4, which is equal to 8. Hence, the number of F minus ions in the unit cell is 8, and all of them are present within the body of the unit cell. The question is, an ionic compound made up of atoms A and B has a face-centered cubic arrangement in which atoms A are at the corners and atoms B are at the face centers. If one of the atoms is missing from the corner, what is the simplest formula of the compound? Let's find the solution for this problem. In a face-centered cubic arrangement, there are 8 corners in the unit cell. Each corner is occupied by atom A except one corner. Therefore, the contribution of the atom A in the unit cell is 7 into 1 by 8, which is equal to 7 by 8. Similarly, there are 6 face centers in this unit cell. They are occupied by atoms B. Hence, the contribution of the atom B in this unit cell is 6 into half, which is equal to 3. Therefore, the ratio of atoms in this unit cell is A is to B, which is equal to 7 by 8 is to 3. On multiplying with the common factor of 8, the above ratio of atoms become A is to B is equal to 7 is to 24. Therefore, the formula of the compound is A7B24. Let's move on to the problems based on voids in close-packed structure. The question is, structure of a mixed oxide is cubic close-packed. The cubic unit cell of mixed oxide is composed of oxide ions. 1/4 of the tetrahedral voids are occupied by divalent metal A, and the octahedral voids are occupied by a monovalent metal B. What is the formula of the oxide? The solution is monovalent metal ion is the metal ion with one vacant position than its original electronic configuration. Same way, divalent metal ion is the metal ion with two vacant positions than its original electronic configuration. The number of octahedral voids is equal to the number of particles present in cubic close-packed unit cell. And the number of tetrahedral voids is equal to 2 into number of octahedral voids. Now let us consider the number of oxide ions in close packing as n. Then the number of octahedral voids will be n. Similarly, the number of tetrahedral voids will be 2 into n, which is equal to 2n. As 1/4 of the tetrahedral voids are occupied by divalent metal A, the number of atoms of the divalent metals A occupying the tetrahedral voids are given by 1/4 into 2n, which is equal to n by 2. As the octahedral voids are occupied by the monovalent metal ion B, the number of atoms of the monovalent metal ion B occupying the octahedral voids is given by n. The ratio of the number of atoms in the cubic close packing or CCP can be given by A:B:O minus 2 is equal to n by 2 is to n is to n. When n is equal to 1, the above ratio becomes A:B: oxide ion, which is equal to 1/1. On multiplying with the common factor of 2, the above ratio of atom becomes A:B:O minus 2, which is equal to 1:2:2. Therefore, the formula of a compound is A1B2O2 minus 2. The next question is, atoms of element B form hexagonal close packing crystal lattice and those of the element A occupy 2/3 of tetrahedral voids. What is the formula of the compound formed by these elements A and B? Solution. Let us consider the number of atoms B in the hexagonal close packing of arrangement as n. Note, the hexagonal close packing of arrangement is also known as HCP. We know that the number of tetrahedral voids is equal to 2 into the number of particles present in HCP. Then the number of tetrahedral void is 2 into n, which is equal to 2n. As the atoms of the element A occupies 2/3 of the tetrahedral voids, the number of atoms in the tetrahedral voids are given by 2/3 into 2n, which is equal to 4n by 3. The ratio of A:B is 4n by 3 is to n. When n is 1, the above ratio becomes A:B, which is equal to 4/3 is to 1. On multiplying with the common factor of 3, the above ratio of atom becomes A:B, which is equal to 4:3. Therefore, the formula of the compound is A4B3.